Hi guys. Today we're going to do everything we learned yesterday. So we're going to answer all those questions like we did in the second video, but we're going to go one step further, which is we are going to be graphing today. Now, attached to today's lesson, I did put a worksheet. So if you have access to a printer, it's highly recommended that you print out the worksheet because we're going to be going through this flow chart. If you don't have access to a printer, that's okay. The flowchart will be at the top of the PowerPoint, or you could always look at it on your computer screen and then copy down the flowchart onto a piece of paper. And on today's paper, we are going to be working horizontally, not vertically. So you want to turn your paper sideways if you are not able to print out the worksheet. In each video for this entire week, I will do one example of a graphing problem. And they're all going to be very similar. The process is always the same. And so it's just we're going to keep practicing until we got the process down. All right, so on our flowchart, the very first thing is the original problem that we'll be working with. So our first problem that we're working with today is y equals x squared minus 2x minus 3. So go ahead and write that down on your flowchart if you printed it out. This is a quadratic equation, which we will be analyzing and graphing. The first thing I like to do on these problems is identify my A, B, and C, because that will be useful for the next steps. All right, so now the first questions that we need to answer are, does this open up or down? Does it have a min or max? To determine that, we need to look at the letter A. If the letter A is positive, then we say it's opening up and it has a minimum. If the letter A is negative, then we say it's opening down and it has a maximum. Now, I just identified my letter A. My letter A is the number 1. 1 is a positive number. So we will say that this parabola is opening up and it has a minimum. Remember, these are answers to questions that will show up on your test. So make sure that you're writing down all of this information. All right, guys, we answered 2 questions. Let's do the next one. The next question is going to be to write the equation for the axis of symmetry. Now, it doesn't want the formula for it. The formula for it is x equals negative b over 2a. It wants you to use that formula to find a final answer. Now, again, I've already identified my b and my a. My b is negative 2, and my a is 1. So I'm going to plug those in. Negative b, negative 2, over 2 times a. The double negative will cancel out, and 2 divided by 2 is 1. Now notice that I kept it x equals. I did not just write the number 1. The axis of symmetry is a line, so it needs to be written as an equation of a line. X equals 1. This is the format for your axis of symmetry. X equals a number. After we have found the axis of symmetry, now we can find the vertex. And we've already found half the vertex. The x-coordinate is the same as the axis of symmetry. It's that number 1. So we just need to find the y-coordinate. To find the y-coordinate, we're going to plug the x-coordinate back into the original problem that we were given, the x squared minus 2x minus 3. Okay, so I'm plugging it in here. No shame in using a calculator, so you can type this into your calculator. Just make sure that you have the notation correct. You have your parentheses, your squares, you're using minus signs where necessary, or you can do this in your head, right? 1 squared is 1, 2 times 1 is 2. 1 minus 2 is negative 1, and negative 1 minus 3 is negative 4. Now this, again, is only half your vertex. The vertex is a point on the graph, so we need to write our final answer as an ordered pair. So I'm not going to put a red box around this. My ordered pair is the 1 from the axis of symmetry, and then the negative 4 that I just found. You want to make sure that you're writing your answers in the correct format. The vertex is a point, 1 comma negative 4. All right, next we're going to find the y-intercept. The y-intercept is also a point, so we write it as an ordered pair. The first number in a y-intercept is always 0. And then the second number for a parabola is the c-coordinate. And I've already identified my number c. It's negative 3. So my y-intercept is 0, negative 3. Look at that, guys. We answered 1, 2, 3, 4, 5 questions. 5 math problems. Now, at this point in time, we need to start doing something that we haven't done yet. So here's where we're going to start graphing. When we graph using our special ordered pairs, which are 1, 1a, 2, 4a, and 3, 9a. Now, before we use those, we're going to use the information that we've already found. So we have determined that the axis of symmetry is at x equals 1. So I'm going to go to the 1 on my x-axis, and I'm going to draw a nice vertical line. It's a dotted line because it does not exist. Or if you have a highlighter, you can use a highlighter to draw that line so that it is not part of the actual graph. And it's always a vertical line. Somewhere on my axis of symmetry will be my vertex. And it is at 1, negative 4. So I'm already at the 1. That's where my axis of symmetry is. And then now I'm going to go down to negative 4. 1, 2, 3, 4, and put a dot. This point right here is my vertex. It is the minimum point of my parabola, the lowest point. It will not go any further than that. From that dot, my parabola, my U shape, will open up. Here's where we're going to use our special ordered pairs. For the special ordered pairs, you're supposed to multiply the y-coordinate by the letter A from the original problem. Now, in this example, and in both of our examples today, the letter A is going to be the number 1. So we can multiply by 1, but it's not going to change anything about the special ordered pairs. So my special ordered pairs are going to be 1, 1, 2, 4, and 3, 9. The special ordered pairs are called special because we don't graph them from the origin. We actually graph them with the vertex as the starting point. So I'm going to put my pencil on my vertex, and from there, I'm going to go right 1 and up 1, and I'm going to put a dot. And then we reflect across the axis of symmetry. So if we go right 1 and up 1, we want the same thing to happen on the left side. So we'll also go left 1 and up 1. Then we'll use our next special ordered pair, which is 2, 4. Now here is important that you always go back to the vertex. So put your pencil back on the vertex all the way down here at the bottom, and we'll do our next special ordered pair, which is right 2 and up 4. And we reflect, so we also go left 2 and up 4. It should be symmetrical on both sides of your axis of symmetry. Next, we're going to do 3, 9. So put your pencil back down on that vertex and count right 3 and up 9. Right 3, up 9. From the vertex. We're not at the number 9. We're 9 above where the vertex was. Now this shape is called a parabola, and it is a U shape. It is a curve. It is not a V shape. We don't want a point down at the bottom. We do want it to be curved. So here is what my graph looks like. And that was new today. One thing I'd like to point out before we answer our very last question is earlier we stated that the y-intercept was at negative 3. So we should check and make sure that we actually put a dot on the negative 3 on the y-axis. So my y-axis is my up and down axis. And here is my dot right here, and that is at 1, 2, 3 down. And so we did good. We put a dot on the negative 3 on the y-axis. So we got the y-intercept correct, and that also confirms that our graph is probably correct. Now, the last thing that we were supposed to do is we were supposed to find our x-intercepts. And there are ways to calculate them, but calculating takes a long time. So we've got a graph. Let's just look at the graph. The x-intercepts, plural, are going to be along the x-axis. And in this problem, there are 2 of them because I put 2 dots on the x-axis. And so I am going to write down an ordered pair for each dot. So 2 total ordered pairs. For this first dot right here, the ordered pair is negative 1, 0. And for the second dot over here, the ordered pair is 3, 0. 2 ordered pairs for 2 dots. This concludes our first example.